Right, in this video we're going to find the general solution of the second derivative minus 4 times the first derivative plus 13y is equal to 0. So to solve is the second derivative minus 4 times the first derivative plus 13y is equal to 0. Again, we let y equal to e to the mx, where m is some arbitrary constant. dy by dx is equal to me to the mx, and then if we differentiate that again, bring the m down, we're going to get m squared e to the mx. And we substitute these into the differential equation. We're going to get m squared e to the mx minus 4 times me to the mx plus 13 e to the mx. I've got a common factor of e to the mx that can come out, and we're going to get m squared minus 4m plus 13 is equal to 0. As as e to the mx is positive, always positive, then the auxiliary equation m squared minus 4m plus 13 is equal to 0. Now, it's not possible to factorize this, so using the quadratic formula, we're going to get m is equal to minus 4 plus or minus the square root of 4 minus 4 squared minus 4 times 1 times 13 over 2 times 1. So that gives that m is going to be 4. Minus 4 squared is 16, and then 4 times 13 is 52, all over 2. And then that comes down to 4 plus or minus the square root of minus 36 over 2, which is 4 plus or minus 6i over 2, and the square root of minus 1 is I, and then obviously both of those cancel down, so we get 2 plus or minus 3i for from the auxiliary equation. Right, so our possible solutions will be y is equal to p e to the 2 plus 3ix plus qe to the 2 minus 3ix. Right, what we do here is we split this up into e to the 2x, e to the 3ix, using the idea that a to the m is equal to a to the m plus n. So we're using this backwards, this idea. And a similar idea here, we're going to get q e to the 2x, e to the minus 3ix. Obviously, e to the 2x is now a common factor, and we've got p e to the 3i plus q e to the minus 3ix. Missing a little x there. Let's add that in. Okay, so now we proceed like the previous video. So using Euler's relation, e to the I theta is cos theta plus I sine theta. We're going to have e to the 2x, p cos 3x plus I sine 3x, as the angle is 3x. And the same here, q cos minus 3x plus I sine minus 3x. And then we use the idea that cos minus theta is cos theta, and sine minus theta is minus sine theta. So this now becomes, this stays the same. And this one here becomes q cos 3x minus I sine 3x. And then we can say e to the 2x of p plus q lots of cos x plus I p minus q, I and p minus q sine 3x, and then we will say that is e to the 2x of a cos 3x plus b sine 3x, where a is p plus q and b is equal to I p minus q. So it's a similar idea, but we've got this extra e to the 2x in. So in general, when the auxiliary equation has two complex roots, p plus or minus q, the general solution is y is equal to e to the px. Has two complex roots, p plus or minus iq, the general solution is y is equal to e to the px, a cos qx plus b sine qx. So this has been a video to show you what to do when you have an auxiliary equation which has roots p plus or minus q iq. I hope you've understood, and I thank you very much for watching.